Okay, today's lesson's on congruent triangles. So what congruent means is they're exactly the same size, exactly the same shape, all the different sides are the same, all the angles are the same, everything's exactly the same. So the notation for congruence, you can see it looks like an equal sign with a little squiggle over it. So in this case, the way we would say this is that triangle ABC is congruent to triangle CDE. You have to be careful with the order, so here we have angle A at the top with that little dash for the angle. So you can see that's the exact same as the angle where C is on the second triangle. And then angle B, if I just put a little dot there for that one, you can see the way the triangles are set up, that would be the exact same thing as D. And then angle C on the top triangle would be the exact same as angle E on the bottom triangle. So when you write these out, you got to make sure you match the angles in the same order. So ABC is exactly the same as CDE for the second triangle. So because they're congruent, all the different angles are the same, but then also the different sides are the same. So you can see they got one arrow for the top side, two arrows for the bottom ones, and then also the three, we could use 3 arrows or something like that to show that that side has to be the same as well. So that means then when we're writing this out, we'd have side AC for the first triangle is the exact same as CE for the second. Side AB for the first would be the exact same as CD for the second. And BC for the first would be the same thing as DE for the second. So all the different sides are the same, plus all the different angles are the same. So angle A equals angle C for the second. Angle B would equal angle D, and angle C on the first is the same as angle E on the second. And you could write them like that, or remember, we can also do it for angle A, you'd say angle CAB. So the line from C to A to B, they're talking about that angle up there. So you could do that for any of them too, but we'll just keep it simple for this stuff. So with congruence, if everything is the same on the triangle, that means all the sides are the same, all the angles are the same, so the triangles have to be the same. So the question is, in order to prove that it's congruent, do we need to have all 3 sides and all 3 angles being given to us to show that they're congruent? And the answer is no, we don't need all 3, we only need certain parts of it to show that they're the same. So there's 3 cases that you need. So there's 3 different cases that show that triangles are congruent, so we'll go through each of the 3 first. So the first case is if you draw triangles and you have all 3 sides. So if you have sides 5, 6, 7 for the first triangle, so let's call this one A, B, C like this, then that has to be congruent to the second triangle because they have the same 3 sides, the 5, 6, 7. And it doesn't matter how we label the triangles, then you would just say that triangle ABC is congruent to triangle, so A is between 5 and 7, so that would be D, B is between our 5 and 6, so that would be F, and then E. So we'd say angle ABC is congruent to triangle DEF. I forgot the little triangle symbol. So ABC is congruent to DEF, and we say that's congruent because of all 3 sides being the same. So to keep it simple, we write it as side, side, side. So all 3 are the same, therefore all the angles have to be the same. It's impossible to draw these triangles differently with those 3 numbers. Okay, you could try it if you want, sketch them out, measure with a ruler, get 5, 6, and 7. You'll always get the exact same shape and size of triangle, it'll never be anything different. The second case that also works is when you have 2 sides of the triangle and the angle in between. So let's suppose I gave you this to be 40 degrees and this side's 5 and that side's 8. And then if we had another triangle, and it doesn't matter how these are drawn, so let's draw this one upside down again. So we have 40 down here and we got 5 there and 8 there. So that'll be the exact same thing, and this time let's call it PQR. Okay, so because we've got 2 sides and the angle between them, we say that those are also congruent. So in this case, we'd have ABC being congruent to R is the same as A, and P would be the same as the B, and Q would be the same as the C. Okay, so those two triangles are the same, and we say they're congruent because of side, angle, side. So once again, it'd be impossible to draw these any other way to get different triangles with those three bits of information. Okay, there's one more that works, and it's similar to this one, except you'd have your triangle with two angles given to you. So let's suppose 20 degrees and 40 degrees, and we'd have a side in between them, like 6. So let's call this one ABC again. And then we'd have another triangle with 20 degrees, 40 degrees, and side 6. And let's call this time XYZ. Okay, so in this case we say these are congruent as well. So ABC in this case is going to be congruent to, so A is the same as the X, B would be the same as the Y, and C would be the same as the Z. So ABC is congruent to triangle XYZ. I forgot our triangle little symbol there again for both. And in this case we say they're congruent because of angle, side, angle. So we have two angles and the side in between them. So those are the only three cases that prove triangles are the same. So side, 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 angle, or angle, side, angle, with those ones that have to be in between the two others. You can't have a different angle. Okay, so there are some other scenarios, but they won't work. So let's do one more different example. So in this case, if I gave you a triangle where we had this angle, and a side over here, so the question is, would that be congruent to another one that would be just like it? So we have 110, the 9, and the 40 like that. So in this case, are these two triangles congruent? Okay, so when we look at them, we would say they're not side, angle, right? Because we got the angle, the 40, we got the other angle, the 10, so we would need this side here to prove it by angle, side, angle. So this is the only one that isn't in the right form. It's not angle, side, angle, but it's still congruent. And the reason for that is we can actually figure out the missing angle just using the 180 rule. So 180 minus 110 minus the 40 would give you 30 degrees. So that means this bottom angle has to be 30 for both. And now that it's 30 for both, we do have the angle, the side, and the angle in a row. So we would say these are congruent, and still by using angle, side, angle. So even though the original triangle wasn't angle, side, angle, if we know two angles, we can always find the third, and then it would be angle, side, angle, no matter what. All right? So let's look at the two cases that don't work. So we've covered 4 cases. 4 work, but really 2 are the same. Angle, side, angle was the same in both scenarios. So the only other case that we have that might not work would be if we had 3 angles like that, and then we had another triangle with 50 and 40. So you could draw these 2 triangles, the exact same 3 angles. We'd have angle, angle, angle. But in this case, you can make any size of triangle having the exact same angles. So in this case, we'd say ABC is not congruent. So because we just basically are blowing up one triangle compared to the other. So in this case, those 2 triangles are not congruent. So angle, angle, angle never works. That's one that's not congruent. And the other case is when you would have one triangle. So let's suppose we have 40 degrees. Let me clean up the triangle a little bit. Let's redo that. Okay, so let's suppose we have 40 degrees on the bottom. Let's suppose this side was 10, and let's suppose that side was 8. So in this case, you can see we got angle, side, side. There's no angle in between. And if I drew another triangle, I could actually draw this one 2 different ways. So I could have 40 degrees down here. We could have side 10 like that, but in this case I could draw the 8 so that it sort of came backwards. So those 2 triangles are possible to draw, having two different triangles are definitely not congruent, but they have the same numbers. So in this case, we would say angle side side is not congruent, but that one doesn't work either. So if we, let's just put letters again. So if we do ABC and XYZ, we would say triangle ABC is not congruent to triangle XYZ. Okay, so this is the only other case that doesn't work. So three angles, angle, 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 one is just blowing up compared to the other, so they're similar triangles but they're not congruent. And in this case, when you have angle side side, you would get two triangles that are totally different but have the same numbers, or two possible triangles, not always, but it is possible. So because you could get a possible case, we would say that one doesn't work either. So to do congruent triangles, you just remember that there's three that work. So side, 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 or angle, side, angle. Those are good ones. Those ones do work. And then the two that don't work, angle, 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 or angle, side, side. Okay, so those are the ones you need to remember that don't work. So angle, 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 just remember that one is similar but not congruent. And ASS, you know what that spells. That's an easy way to remember that it doesn't work as well. And that's it.